Alright, welcome folks. So, being that it's a snow day, but I don't want you to miss out, we are going to have a few short videos to help you follow along with the material we would have covered on Tuesday, January 14th. So we were just going to begin Chapter 2, which is discussing the atom. So we will discuss Chapter 1 and the measurements lab more when we can meet in person. So that'll be delayed on its due date so we get a chance to talk about it in class. We're focusing on the new material in the chapter, and so we're going to talk about Chapter 2. Chapter 2 talks about the atom itself. So chemistry is the study of the universe around us, all the physical stuff that makes up reality. Well, that stuff is organized here. This is the periodic table of elements. We can see way over on the top left. So, well, it's not letting me highlight it. Way over on the top left, there's the H symbol. That is the hydrogen. Goes all the way across to the right. There's the He symbol in the top right. That is the helium. Right? They have a symbol. We use one or two letters to tell us what element we are discussing. And while there are, on this you'll notice there's 118, we won't talk about most of them. We're going to stick to mostly the earlier ones. But let's just start with those two. Let's talk about hydrogen and helium and what that difference really is. So on the periodic table, we had a box. It had a hydrogen in it. And way over on the other side there was a box and it had He in it. Well, the H symbol represents hydrogen, and the He symbol represents helium. And most of the time, but not always, the symbol kind of makes sense with the name. There's only so many letters and there's way more elements, so some of the symbols don't quite make as much sense. We'll discuss some of them in class, but let's focus on these two. When I want to talk about a hydrogen atom, I just can talk about H. I don't need it in the box, I can just write H. If I want to tell you that there's multiple of them, well, remember so I don't think let's start with it. So if I want to talk about multiple hydrogens, I just put a little number in the lower right. If I have H2, that is telling you that there are two hydrogens there. If I have H2O, well, the element O is oxygen. It's actually element number 8, hydrogen's element number 2, hydrogen was number 1. We'll go look at the periodic table again, and you can see that symbol. There's a 1 above the hydrogen. There's a 2 above the helium. And if you look at number 8 here, the oxygen, it's got an 8 above it. We'll talk about what those numbers mean in a second, but most of us are familiar at this point with water. Water is made up of 2 hydrogen atoms and 1 oxygen atom. Now, we introduced terms the first day. Remember, atoms were the individual building blocks. Molecules were what happened when you brought multiple atoms together. So water is a molecule. And because the 2 types of atoms are different, it is also a compound. Where if we look just at H2 over here, well, there's 2 atoms, so it is definitely a molecule, but it is not a compound. Their elements are the same. And if you have helium, helium actually only shows up free floating. There's only ever 1 helium, and if there's only 1 of something, we don't write the number. You'll notice there was no 1 after oxygen. We wouldn't put the atom there unless there was at least 1. Like there's no sulfur 0, carbon 0, or other elements. So if we have the element symbol, we must have at least 1, so we don't bother writing the 1. There's other compounds that we see regularly kind of society. Carbon dioxide, CO2, is 1 carbon and 2 oxygens. Methane, fairly common natural gas if you have gas heating, is 1 carbon and 4 hydrogens. So the idea is these letters, whether it's 1 or 2, so an H, an O, an HE, a carbon, a C, these letters represent the different elements, the different types of atoms that exist. And so each atom behaves very differently. Each needs its own symbol, so we can tell you exactly which atom we are working with on a molecule. Well, let's talk about what's different between the atoms. I have a hydrogen again, and I have a helium. We used to think that they were small little circles, little balls, and that they each were just unique, and there was just something naturally different about them, and that was it. We now know they are actually made up of more things. We call them subatomic particles, so smaller than the atom. Those particles are protons, electrons, and neutrons. Protons get the symbol P with a plus, electrons get the symbol E with a minus, neutrons get the symbol N with nothing. Protons are actually positively charged, and electrons are negatively charged. Think magnets. You've got a north end and a south end. They have opposite attractions. This is what's going on with protons and electrons. Well, what happens is, at the very center of an atom, your protons, which I'll draw as a circle with a plus, they'll hang out with any neutrons, which we'll draw as just a circle with no charge. This is the nucleus. They are stuck together in the very center. Outside of them are the electrons. So the electrons aren't in the nucleus. They are, and this is not to scale, they are very far away. If you had a proton the size of, say, a pea, a little green pea food, the electrons would be 100 meters away by comparison. They are very, very far from the nucleus by comparison for their size. Well, this is the modern atomic construction. This is the nuclear model of chemistry. That there is a small little gathering in the center of all your protons and neutrons, and then way outside of them are your electrons. Well, depending on your mix of protons, neutrons, and electrons, you have different types of atoms. So let's talk about what any of those changes mean. First and foremost, protons define the atom. So what that means, if I go to hydrogen and I look at its number of protons, well, it's 1. Helium's number of protons is 2. Go back and look at the periodic table real quick. Hydrogen is the first element. It is the first element because it has 1 proton. Helium is the second element because it has 2 protons. If anything ever changed the number of protons, they would be a different atom. In fact, that actually does happen rarely. Our sun takes 2 hydrogens and smashes them together to make heliums. By squishing 2 protons together, it makes a new atom. That's what the sun actually does to make heat. It's fusion. If we look number 3 over here, lithium. Lithium over here. Let's see if I can highlight it there. Nope, won't let me do it. Lithium is the third element. it has 3 protons. Beryllium is the 4th element, it has 4. Boron is the 5th element, it has 5, and so on. Carbon has 6 protons, nitrogen has 7 protons, oxygen has 8 protons, and so on and so on. The number of protons tells you what the atom is. So all heliums, no matter what else changes, all heliums have 2 protons. All hydrogens, no matter what else happens, always have 1. Well, let's look at that atomic symbol for a minute. We're going to need to do a few more things to it if we want to talk about our electrons and our neutrons. So let's draw a generic element symbol. So this could be a hydrogen, it could be a helium. I'm just going to call it X. There are 4 spaces around our element symbol where we put information. So around our heliums or our hydrogens, we could fill in info in those spaces if we want. We've done this once. The lower right told us the number of atom in molecule. So when we had H2, we filled in the lower right with the number of hydrogen atoms. So that's what the lower right tells us. What's important for electrons, neutrons, and protons are the top 2, though. The top left is the number of particles in nucleus. Remember, only the protons and the neutrons show up in the nucleus. So if I have H1 and I have H2, well, let's think about drawing it. I'm a hydrogen, so let's just look at our protons and our neutrons. I'm a hydrogen. I must have 1 proton. So both of them, there is 1 proton. And our first one over here on the left, well, there's only 1 thing in the nucleus at all. So I've already used it. It's used with protons, so there are no neutrons. This would look like a nucleus with a single proton, and, well, we haven't discussed the electrons yet. The electron would be around it. But over here for H2, well, 2 things are in the nucleus, one of which was used by a proton. Well, that means there's 1 left over. So that leftover one must be a neutron. This would mean I have 1 proton and 1 neutron, and then my electrons around them. This can happen. You can have different numbers of neutrons on the same element. When that happens, so same element with different neutrons, are called isotopes. So these are both isotopes. They are both called an isotope. They are both isotopes of hydrogen. Because they each have only 1 proton, they are hydrogen atoms, but they are different isotopes of hydrogen. One having more neutrons, one having less. So that upper left symbol is really useful for figuring out what's going on in terms of the neutrons on your atom. Let's talk about that top right. The top right is the number of charge on atom. So let's think about these again. Charge, that means our overall pluses and minuses. When I think of either of these, I have a single plus and a single minus in both cases. Well, if I plus 1 and minus 1, I end up at 0. There's no charge on those. And you'll notice we didn't put any charges in the top right corners. I should use a different color. Let's try that. So those hydrogens, they had one electron and one proton, so they had no charge and it was left blank. But it is possible for you to have things like hydrogen plus. And let's say it's H1 plus and H2 with a plus. Well, let's think about our protons, our neutrons, but let's also think about electrons this time. As before, each hydrogen has one proton. That is what it means to be hydrogen. Our first hydrogen has no neutrons. It only had one thing in the nucleus, so it has 0 neutrons. Our second hydrogen here has 2 things in the nucleus, so 1 is a proton. The remaining 1 is a neutron. And now, my hydrogen needs to be plus 1 overall. Well, it comes with a single plus. If I have any minuses, that will go away. So I must have no minuses. And so for both of these, this would look like just the nucleus. There's a proton, or there's a proton and a neutron. There are no electrons around them. If you had an element like, let's say, helium-3, and we're going to give it a plus charge. Just for comparison, let's look at helium-3 when it's neutral. Well, there's protons, neutrons, and electrons. Protons, neutrons, and electrons. To be helium is to have 2 protons. So each of them must have 2 protons. They are helium. Well, there's 3 things in the nucleus, and only 2 of them were taken up by protons. So there's 1 left over to be a neutron, and that's true in both cases here. And now we go to electrons. Well, I need a single positive overall, and I have 2 positives from my protons. So I need one of those positives to go away. I need 1 negative charge, so I need a single electron. This would look like a proton, a neutron, a proton, and a single electron around them. If I go and look at my other helium here, it doesn't have a charge. So there are 2 positives. I need to make them both go away. So I need 2 negatives to make them go away. Basically, plus 2 minus 2 is equal to 0. So for this symbol, for He3 with no charge, I must have 1 proton, 1 neutron, my second proton, and around it would be 2 electrons. So this is how we look at the symbol in order to determine what the parts of the atom are that we're talking about. So let's do a practice here. Let's scroll down. Take a sec. Helium-4, lithium-6, carbon-12, carbon-13. Let's give a plus charge on that lithium. So reference the periodic table, use these symbols, and write for me in each case the protons, the neutrons, and the electrons for each of these. So go ahead and pause the video and give that a try, and then come on back. Alright, if you gave it a shot, let's look. To be helium means I must have 2 protons. So 2 of my 4 things in my nucleus are taken up by protons. Well, there were 4 total things. 2 of them were protons. So there are 2 left over. My neutrons must be 2. If I look at my electrons, well, I have no charge. My charge is left blank. So I have no positives or negatives overall. But I know I had to have 2 positives to be helium. So I must cancel the 2 positives with 2 negatives. I must have 2 electrons. So my helium-4 with no charge has 2 protons, 2 neutrons, and 2 electrons. Let's look at my lithium. Lithium was the 3rd element, so it must have 3 protons. Well, there are 6 things in its nucleus. 6 minus 3 leaves me 3 left over. So there must be 3 neutrons. In terms of electrons, I want a plus charge overall. Well, I have 3 positives from my protons. I only want 1 to be left, so I need to get rid of 2 of them. So I must have 2 electrons. If I go to carbon 12, carbon is the 6th element. It must have 6 protons. Well, there's 12 things total in its nucleus, so 12 minus 6 is 6. It must have 6 neutrons. And there's no charge again. Whenever you have no charge, your electrons must equal your protons to cancel them all out. So it must have 6 electrons. If I go to carbon 13, however, well, it's still carbon. It is still only 6 protons. That is what makes it carbon. Well, 13 minus 6 leaves me with 7 left over, so I must have 7 neutrons. So carbon 13 has 1 more neutron than carbon 12 did. In terms of electrons, though, I'm still without charge. It was empty. So I must have just as many electrons as protons. And so we can see that the only difference between isotopes is that our neutrons go up. So carbon 12 and carbon 13 are isotopes of carbon. And the only difference between them is that their neutrons is different. Alright, I'm going to break this video, but that is the introduction to reading an atomic symbol, recognizing the parts that make up an atom, and being able to identify how many of each part there are.